past, we would have bird flu outbreaks maybe every 10 years. More recently, I think it's been every couple of years and verging on just a continuous kind of low-level presence of bird flu generally. In our lab here at the University of Michigan, we've been working on using plasmas as an alternative to filters to protect against airborne viral pathogens. And what we've shown is that we're able to inactivate viruses 90 or 99%, but we're able to do so without impeding the airflow. Traditionally, pig farmers and chicken farmers, especially in winter, have limited how much outside air they bring in order to minimize heating costs. If influenza is in your birds, and if your birds are shedding it in aerosol form, you may be putting yourself at greater risk for influenza spread because the pH of the aerosols is being driven by these high concentrations of ammonia or hydrogen sulfide to a pH level that preserves virus infectivity rather than promotes loss of infectivity. Our goal is to examine that process and use a method that we developed in our lab to directly indicate which way do these gases drive pH. Do they drive pH higher? Do they drive pH lower? And does that lead to a retention of virus infectivity? Or does that drive a more rapid loss of virus infectivity? The goal is to develop a device either for building ventilation systems or for PPE, personal protective equipment. If these gases around livestock interfere with the plasma and reduce its effectiveness, can we increase the power to the plasma to overcome that? So that's one of the big objectives of this grant.